Section 7.2, ratios in similar polygons. These are the objectives. Identify similar polygons. Second one, apply properties of similar polygons to solve problems. Vocab, similar, similar polygons, similarity ratio. Follow along, says figures that are similar, and this is the symbol that we use to represent the word similar. Have the same shape, but not necessarily the same size. Here's an example of two figures that are similar. Notice that they have the same shape, but not necessarily the same size. An example of some two figures that are not similar, because this looks like an isosceles triangle, this looks like a right triangle. They don't have the same shape at all. Anyway, let's move on. I want you to write this. It's very important. It says writing a similarity statement is like writing a congruence statement. Be sure to list corresponding vertices in the same. Be sure to list corresponding vertices in the same order. Next slide. Important definition. Follow along, says two polygons are similar if and only if. This is a biconditional statement. Their corresponding angles are congruent and their corresponding sides are proportional. So angles must be congruent, corresponding sides must be proportional. So notice that angle A is congruent to angle E, angle B congruent to angle F, and you can read the other two. Now, this is the corresponding sides are proportional part. Notice that I have, let me see, I have AB, so AB over EF. If I take 6 over 12, I write a ratio, and it simplifies to 1 over 2. In the same manner, if I do BC over FG, I have 5.4 over 10.8. I simplify this fraction and I get 1/2. You should be able to follow how we get 1/2 for the other two as well, these two. So this is a definition of similar polygons. And notice that we're using the symbol they use that represents the word similar. And again, they are the same shape, but not necessarily the same size. That's what it means to be similar. Next slide. Says identify the pairs of congruent angles and corresponding sides. So let's look at the angles. Angle N and angle Q are similar. Why? Because they're 90-degree angles, and also 63 and angle P and angle R, because they're both 63 degrees. Why is angle M congruent to angle P? Because of the third angle there. So these are your corresponding angles. Now let's go to the sides. You should be able to follow. Let me just highlight. So you have MP corresponds to, notice that this is the hypotenuse. The hypotenuse corresponds to the other hypotenuse, and that's why you have MP over TR, and once you write the ratio, you end up with 2. And then MN corresponds to TQ. Why to TQ? Because look at the three sides. This one is the side that has the middle length. So out of these three sides, which one has a middle length? You know it cannot be this one, because you know it's the hypotenuse one, so it's going to have to be this one. But if you compare the numbers, you should be able to see that this is the middle side length. That's why I have 2 over 1, and you end up with 2. Same thing here, and they all equal to the same ratio. Let's move on to number 2. So it's the same directions as number 1. Let's look at the angles. B is congruent to G. C is congruent to H. They're both 59. These are 90-degree angles. And by the third angle theorem, I click too soon. But anyway, angle A is congruent to angle J by the third angle theorem. Now let's look at the sides. Notice that this is the longest side, so correspond to this one. Let me change the color. This is the, out of these three sides, this is the smallest side length, so then it has to correspond to this one. And you have no choice, but this one is going to have to be corresponding to this one. Once you write your proportions, notice that you get 2. Let's move on to the next slide. Follow along. Very important concept, similarity ratio. This is what it reads. It says a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. This picture will clarify it. This is what it says. The similarity ratio of triangle ABC, which is this triangle, to this triangle, is 1 to 2. How do you get that? Take this side over this side, and notice that you get 3 over 6, but this reduces to what you have here. What happens if you switch the order? You look at the similarity ratio of triangle DEF, which is this triangle, to this triangle. Then you go, let's pick this side, 6 over 3, which gives you 2. Okay? And again, let me emphasize this. Hence the order. Depending on which order you go, you get a different number. Let's move on to the next slide. Here's number 3. It says determine whether the rectangles ABCD and EFGH are similar. If so, write the similarity ratio and a similarity statement. So how are we going to show that determine if these are similar? So what we're going to do is we're going to see if corresponding angles are congruent and corresponding sides give us the same ratio. So here's the first part. Identify pairs of congruent angles. And this is what we have. All those angles are congruent. Why? Because we are dealing with a rectangle. Actually, we're dealing with rectangles. And all angles in a rectangle are 90 degrees. So that's why we have this. Step 2 says compare the ratio of corresponding sides. So you should be able to follow along. AB to EF gives us 3 halves once we simplify. BC to FG also gives us 3 halves. CD to GH, 3 halves, and you should be able to follow the last ratio of corresponding sides. So from here, the similar ratio is the same. So then we conclude that rectangle ABCD is similar to rectangle EFGH. Let's go to the next slide. Oh, I forgot about this. What is the similar ratio of these two similar triangles? 3 halves. So here's number 4. Determine whether triangle PQR and triangle STW are similar. If so, write the similarity ratio and a similarity statement. Every single one of you should be able to see where I get these angles from. If you don't, well, that's not a good sign. But if you want me to clarify, talk to me in class. So from here, we can conclude the following. Since no pairs of angles are congruent, the triangles are not similar. Let's go to number 5, and this will be the last one. Here's number 5, the last one. Determine if triangle JLM is similar to triangle NPS. If so, write the similarity ratio and a similarity statement. So if you look at the angles, I have angle N is congruent to angle M because they're right angles. Angle L is congruent to angle P because it's given information, and S is congruent to J because of a third angle term. Now let's look at the corresponding side lengths. So we're looking at LJ, which is the longest side in the triangle. 75 corresponds to 30. And 75 over 30 reduces to 5 halves. And then have LM over PM. Why? Because 60 and 24 are the middle segment lengths. and then I get 60 over 24, and I get 5 over 2 once I reduce. And then the smallest segments are, I should have used a different color for 60 and 24, but anyway, the smallest side lengths are 45 and 18, so those correspond. So 45 over 18 reduces to 5/2. Since corresponding sides give me the same ratio, I can conclude that triangle LMJ is similar to triangle PNS. And this concludes the video.